Okay, so we're going to do the next three problems on the list. So we have 41. So I think the next couple are they're equalities, but they start out as fractions. And really, we just have to do one thing to make it into a form that is exactly the same as the one that we've just been dealing with. Okay, so that's the equation. So what you want to do is we want to get this like the previous problems that we've done. So we want to multiply every term by the same number to maintain the equality. And what you look for is the least common multiple of the denominators. So in this case, it's easy to see that the least common multiple is actually equal to 6. Because 6 is the second multiple of 3. 3 times 2 is 6. 6 is the first multiple of 6. So what we do is we multiply by that least common multiple. So I'm just going to show it by putting these in parentheses and then putting the 6 outside the parentheses. So I'm showing you them multiplying everything. Again, if you do the same thing to either side of the equality, then it remains an equality. So basically what we have here is 4x plus 1. We just read this out. 4x plus 1 parentheses over 3 times 6. X plus 5 parentheses divided by 6. So what I've done is I've removed the parentheses from the denominator because it's just a single number. I forgot to multiply by 6. Okay. Now, when you have just pure multiplication and division like we have here, and that's true if you treat this term in the parentheses as a single quantity, then we can simplify. So you have 6 divided by 3, which is 2, and then you multiply by the third term, which is the term in the parentheses. Here I have 6 divided by 6 is 1, and you have 6 divided by 6, which is 1. So now we have an equation that doesn't have these fractions. So we do the same thing that we did before. We're going to multiply 2 times each term in the first parenthesis. So you'll have 2 times 4x, which is 8x. You'll have 2 times 1, which is 2. And then on the right-hand side, I put these in parentheses because they're in parentheses here, but because there's no number, explicit number out here, basically we're multiplying by 1, we just remove the parentheses. 1 times x plus 5 is x plus 5, and 1 times x minus 3 is x minus 3. Okay. Now we combine like terms. So on the right-hand side, we have 1x and then another x, so that's going to be 1 plus 1 is 2, so we get 2x. We have 5 minus 3, which is 2. Now, what we're going to do is we're going to solve for x. So we want to have this constant be removed from the left-hand side. So we subtract 2, but to balance the equation, we subtract 2 again. And then we're going to subtract 2x from both sides so that we can remove the variable term from the right-hand side. Again, we do it to both sides. So you get 8x minus 2x. 8 minus 2 is 6. 2 minus 2 is 0. 2x minus 2x is 0. 2 minus 2 is 0. So the right-hand side becomes 0. You divide both sides by 6. So 6 divided by 6 is 1. We get 1x, which is this x. 0 divided by any number divided by, well, 0 divided by any number is 0. So the answer is 0 is a solution. So 0 is a valid solution. Okay, next problem. 44. So that was how you handle fractions. This next example is how you handle decimals. And the easiest thing to do is to get rid of the decimals, just like we got rid of the fractions in the previous example. Okay, so rather than multiplying this by each term in here, it's better to first multiply by some multiple of 10, not multiple of 10, decade, meaning 10, 100, 1,000, so that you can get rid of these decimal points. So because we have 2 decimal points, this number is 2 decimal points to the right of the decimal point. And this one is also 2 decimal points to the right. We're going to multiply by 100. We'll multiply everything by 100. So you get 0.09 times 100 times x plus 0.13 times 100 times x plus 300. And that's equal to the right-hand side, which is, take 61 times 100. So I've multiplied everything by this, every term by the same number. Well, if you multiply 0.09 by 100, you get 9. If you divide multiply 0.13 by 100, you get 13. And if you multiply 61 times 100, you get 6,100, or 6,100. So again, we're now back to just a simple equation. So first step, once we do that, the second step, after we multiply by 100, 13 times x is 13x. 13 times 300, well, you can use your calculator for that. 13 times 300, 3,900. That's equal to 6,100. Okay, so got rid of the parentheses, combine like terms. 22, 9 plus 13 is 22. So we've gotten our left and right hand sides into just a term involving x and a constant term. We subtract 3,900 from both sides. Do the same thing. So the left-hand side just becomes 22x. This becomes 0. 6,100 minus 3,900 is 2,200. Divide both sides by 22. You get x is equal to 100. And then the final one of this group is 52. Okay, so this next one is a different question. So there are 3 things. There is whether an equation is conditional, an identity, or a contradiction. So conditional is mostly what we've been doing. If you end up with where the x values cancel out and you just end up with something like 6 equals 6, that's an identity, which means that it doesn't matter what value of x is, the equation is satisfied. And a contradiction will be when you get something like negative 6 equals 0, where the x's cancel out, but the constant terms are not the same on both sides of the equation. So all these ones where we're solving for x are conditional. They're conditional based on a value of x satisfying the equation. So if we do 52, we'll get negative 6x plus 2x minus 11 is equal to negative 2 times 2x minus 3 plus 4. Okay, so we don't know anything different this time. We just go through the same procedure. So we first thing we're going to do is multiply this out so that we get individual terms and no parentheses. So negative 2 times positive 2 is negative 4. So we get negative 4x. Negative 2 times negative 3 is positive 6. And then we add 4. Okay, combine like terms. Negative 6 plus 2 is negative 4x. We only have one constant term here. We get negative 4x. 6 plus 4 is 10. So if we add 11 to both sides, and we add 4x to both sides. Again, the reason I'm doing this is to remove this from the left-hand side and move this from the right-hand side. So you've got negative 4x plus 4x, that's 0. Negative 11 plus 11 is 0. So you get 0 on the right-hand side. These cancel out. Negative 4 plus 4 is 0. But when you add these two together, you don't get 0, you get 21. And because this is not true, since 0 does not equal 21, we have a contradiction. Now, if this number here had been, let's see if that number, I'm not sure what it would have to be, but there's a number here that I could change that, and you'd end up with 0 equals 0, and that would be an identity. Okay, so that's it for that group.